Hello, my name is Jonathan Mark Dietrich, and today I'm going to give a presentation on quantum mechanics. I'll be discussing some general concepts, some basic principles, and recent progress that's been made in the field. So let's get started. An introduction to quantum mechanics. So what exactly is quantum mechanics? Well, quantum mechanics emerged in the early 20th century as a fundamental theory used to describe the behavior of particles at the atomic and subatomic level. And some major physicists that have made big advancements and revolutionized our understanding of how this works are Albert Einstein, pictured on the top right, and Niels Bohr, pictured on the bottom right. They are physicists that have been laying the groundwork for technical advancements that we use today in the field of quantum mechanics. Some general concepts. We have three probably of the most popular concepts of quantum mechanics, and let's start with superposition. Superposition is the statement that particles can exist in multiple states at the same time until they're measured. This has been represented by the famous Schrodinger's cat analogy. We also have entanglement. When particles become interconnected, their states are linked regardless of distance, leading to correlations between them, thus being entangled together. And we have the wave-particle duality. This states that particles can exhibit both wave-like and particle-like behavior. And this concept has challenged a lot of classical physics notations of how particles can be at two states simultaneously. Let's look at some basic principles in the field of quantum mechanics. First, probably most famously, is Heisenberg's uncertainty principle, which he won a Nobel Prize for. And that states that when it comes to a particle very, very small, you can either know how fast it's going or where it's located, but not without both being at the same time without being uncertain. And we also have Schrodinger's equation. And this is at the core of quantum mechanics. It describes how a wave's function evolves over time, and it links that system's energy to changes in its quantum state. And this provides insights into how being allowed energy levels and the behavior of particles on a fundamental scale. These are some basic principles in the field of quantum mechanics. Let's move on and talk about some recent progress made. Specifically, recent progress made in the field of quantum teleportation. So what is quantum teleportation? Well, it's what transfers quantum information between particles by entangling them, as we discussed earlier, allowing the state of one particle to be recreated in a distant particle. Using entanglement in classical communication, it enables the transfer of quantum states while altering the original, this showing promise for secure communication. And what do we mean by secure communication? Well, this means that it can be encrypting data through the transfer of quantum states. And it enables an unbreakable encryption, as any interception or measurement of the transmitted information would alter the original. So this would ensure very, very secure communication channels that we can use. Thank you for listening and following along with my presentation on quantum mechanics. Have a nice day.